That's good. Okay, sorry everyone, and again, hello, and thank you for joining me today. Let me again. Okay, I'm Raity Vojdani, and in this session, we will dive into some exciting concepts in C Sharp. We will be exploring tools like .speak, the process of debugging, and various data types, among other things. So let's get started. Let's begin with .pig. .pig is a .NET compiler and assembly browser from JetBrains. It's used primarily to decompile .NET assemblies and view the original source code. This tool is especially useful for debugging your own code when the source isn't available. Some key features include the ability to explore assemblies, navigate to source code, and analyze dependencies. Here you can see a screenshots of the .big interface. Now let's talk about debugging. Debugging is the process of identifying, analyzing, and removing errors in the code. In Visual Studio, you can start debugging by setting breakpoints and running the code in debug mode, which allows you to step through the code line by line and examine the state of the application. Are essential tools in debugging. They allow you to pause the execution of your code at the specific points to examine the current state. There are different types of breakpoints, including standard breakpoints, trace points, conditional breakpoints, and function breakpoints. And here are images showcasing the different types of breakpoints in action. As you can see, each type provides a different way to control and monitor the flow of our program during debugging. Visual Studio offers several debugging windows that are extremely useful. These include the immediate window, watch window, locals window, and call stack window. Each window serves a specific purpose and helps in monitoring the state of your application during a debugging session. The immediate window is a powerful tool that allows you to execute code and view results during debugging. And the watch window is used for monitoring variables and expressions. You can add variables to the watch window to keep track of their values as you step through your code. This is very helpful for understanding how data changes over time. The local window displays all the local variables in the current scope and their values. This provides a quick overview of the state of your application at any given point in the execution. Now let's move on to C-sharp data types. In C-sharp, data types are categorized into reference type, value types, and pointer types. Understanding the differences between these categories is fundamental for effective programming in C-sharp. Value types store data directly in memory, typically on the stack. Examples include int, double, and struct. On the other hand, reference types store references to the actual data, which is located on the heap. Examples include classes, string, and array. Next, we will discuss enums, structs, and classes in C Sharp. These are some of the fundamental constructs in the language, each serving a specific purpose in organizing and managing data. Uh, okay, I think, yeah, I lose this page. Enums in C Sharp are a special kind of value type that consists of a set of named constants called the enumerator list. Enums are useful for representing a collection of related values in a clear manner. Here is an example how to define and use enums in C Sharp. Structs are value types that are used to encapsulate small groups of related variables. They are useful when you want to create lightweight objects that have similar properties to classes but are more memory efficient. And here is how you can define a struct in C Sharp. Classes are reference types and are used to create objects that encapsulate data and behavior. They are more versatile and can support inheritance, which structs cannot. And here is an example of how to define a class in C Sharp. Okay, deciding whether to use structs, enums, or classes depends on the specific needs of your application. Structs are ideal for small, simple objects that don't require inheritance, and enums are perfect for defining sets of relative constants. And classes are best suited for more complex objects that require encapsulation and inheritance. And here are some examples to illustrate these scenarios. Let's see the code in our Visual Studio, and let's put what we have learned into practice by writing some code before we say goodbye. Let me go. Okay, I have written these lines before my presentation, and I said that when we want to create an enum, we should use enum keyword and our favorite name. I call it employee type here, and the constants of the employee type that I defined it is sales manager and research. And now we want to see how we can use these enums. Okay. Here I wanted to create a method to use this enum, but I don't see. Okay, let me. Yes. Okay. Here is my function that I defined a calculate function that have these arguments and base weight and employee type that I called it employee. And in the body of my function, I defined a result and I set the block of condition and it checks if employee is equal to employee type the manager field, then it puts a base weight to the result, and else it's assigned 20 to our result. So in the end, it's console, yeah, it logged the result. And in our body of the main method, I define a base weight and then I create a new variable of employee type and I assign employee type manager to it, and then I called my function. And let's see the result. Okay, as you can see, our result is 3 and it works fine because this condition is true. So base weight is assigned to the result and our base weight was 3. So let's create a struct now and see how we can work with structs. Let me. Okay, I want to define a struct. So I use a struct keyword, its name, and curly braces for its body. I want to define, for example, public int ID, and because all employees has an ID and name, and let's define public void work method. And in the body of our method, I want to log the fields of our struct. Okay, for example, name is working. And let me call it. So first we have to create a variable, and then employee dot id field, I want to give it, for example, 3. And to its name, I want to give it my name, for example, Raity. And then let's call our method employee.work. Okay, let's see the result. Yeah, Raity is working. As we expected, it logged this line for us, and we have learned how we can use struct. Okay, and now let's create a class. Let me remove this. Okay, for defining a class, you can right click here and go to add and then new item and select class, and here you can change its name. Okay, for our class, I want to define some fields, for example, public. Okay, first, let me define its constructor as it's suggested. Okay, be careful. Your constructor name and your class name should have the same name. And here, public string name. We don't use this part. And name, and then I want to give it ID field. And then it should be integer. And then date time, birthday. Okay, in our constructor, I want to define the field, the string first name and int ID and date time birthday. Okay, let's initialize it, and yeah, give first name to our name in the class and give ID and birthday. Okay, let's define another method in our class. For example, public void work, and log these fields. Console write line, and for example, name works on birthday. Let's save it and let's see how we can use our class. Okay, in our main function, first we have to create class 1 type. Class 1, for example, I want to name it employee. And then new class 1, and we should give it its arguments for its constructor. And for first name, I give it Raity, and for ID, I give 2, and for date time, new date time, for example, 3 and 5, and that's it. Let's see the result. Okay, we didn't get anything. Let me see. Because we didn't set its function. We didn't call its function employee work. Now let's see. Yeah, Raity works on this date time. As we expected, this line is called and is shown to us. Okay, that was my presentation, and thank you all for joining. And I hope you find this session helpful. Bye everyone. Okay.